Hello, welcome to Weekly Raids. We raid information and deliver to your screens weekly. This is a new science and technology channel, so subscribe and share the video. This video is about the Y2K bug, which brings shivers to many developers. Let's start. So first of all, what is a software bug? Imagine you turn on your computer and it boots up and suddenly crashes. If you try again, it turns on perfectly. Few days later we experienced same problem. After a while it becomes troublesome. This is all due to a fault in the OS or an application in our system. That daily causing factor is referred as a bug. The bug may be in fact a huge program mistake or even a minute error in the code that gives you some undesirable result. These bugs need to be found and solved immediately. Or else it may cause damage to the machine itself. Let's see what happens after a developer encounters a bug and can't solve it for hours. So now that we have known what's a bug, we will go back in time when these bugs were discovered. It was in 1870s that inventors like Thomas Edison found bugs in their inventions. They described it as faults and difficulties. It was very hard to overcome these bugs in those days. Thomas Edison is said to be terming the word bugs for these faults. Many such bugs were reported in arcade games, which were popular in the 1900s. Many military weapon faults were also called bugs. So over all these years of finding about bugs, programmers should be able to rectify them easily. Isn't that what you think? The problem is when you try to solve a bug you may end up creating another bug, which has a counter effect to the primary bug but has its own faults. Overall, apart from this there is a mighty bug, which is considered to be king of all bugs, or so I like to call it, the Y2K bug or Y2K problem, and most famously referred as the millennium bug. Y2K bug, also called year 2000 bug or millennium bug, a problem in the coding of computerized systems that was projected to create havoc in computers and computer networks around the world at the beginning of the year 2000. After more than a year of international alarm, feverish preparations, and programming corrections, few major failures occurred in the transition from December 31, 1999, to January 1, 2000. Until the 1990s, many computer programs, especially those written in the early days of computers, were designed to abbreviate 4-digit years as 2 digits in order to save memory space. These computers could recognize 98 as in 1998 but would be unable to recognize 00 as 2000. Perhaps interpreting it to mean 1900. Many feared that when the clocks struck midnight on January 1, 2000, many affected computers would be using an incorrect date and thus fail to operate properly unless the computer's software was repaired or replaced before that date. Other computer programs that projected budgets or debts into the future could begin malfunctioning in 1999 when they made projections into 2000. In addition, some computer software did not take into account that the year 2000 was a leap year. And even before the dawn of 2000, it was feared that some computers might fail on September 9, 1999, because early programmers often used a series of nines to indicate the end of a program. It was feared that such a misreading would lead to software and hardware failures in computers used in such important areas as banking, utility systems, government records, and so on, with the potential for widespread chaos on and following January 1, 2000. Mainframe computers, including those typically used to run insurance companies and banks, were thought to be subject to the most serious Y2K problems. But even newer systems that used networks of desktop computers were considered vulnerable. The Y2K problem was not limited to computers running conventional software. However, many devices containing computer chips, ranging from elevators to temperature control systems in commercial buildings to medical equipment, were believed to be at risk, which necessitated the checking of these embedded systems for sensitivity to calendar dates. Centers of technology, such as power plants, were also threatened by the Y2K bug. Power plants depend on routine computer maintenance for safety checks, such as water pressure or radiation levels. Not having the correct date would throw off these calculations and possibly put nearby residents at risk. Transportation also depends on the correct time and date. Airlines in particular were put at risk, as computers with records of all scheduled flights would be threatened. After all, there were very few airline flights in 1900. Y2K was both a software and hardware problem. Software and hardware companies raced to fix the bug and provided Y2K-compliant programs to help. The simplest solution was the best. The date was simply expanded to a 4-digit number. Governments, especially in the United States and the United Kingdom, worked to address the problem. In the end, there were very few problems. A nuclear energy facility in Ishikawa, Japan, had some of its radiation equipment fail, but backup facilities ensured there was no threat to the public. The US detected missile launches in Russia and attributed that to the Y2K bug. But the missile launches were planned ahead of time as part of Russia's conflict in its Republic of Chechnya. There was no computer malfunction. Countries such as Italy, Russia, and South Korea had done little to prepare for Y2K. They had no more technological problems than those countries, like the US, that spent millions of dollars to combat the problem due to the lack of results. Many people dismissed the Y2K bug as a hoax or an end-of-the-world cult. Programmers wanting to avoid the Y2K bug had two broad options: entirely rewrite their code, or adopt a quick fix called windowing, which would treat all dates from 00 to 20, as from the 2000s, rather than the 1900s. An estimated 80% of computers fixed in 1999 used the quicker, cheaper option. This would help them avoid difficulties and keep in tune with the exciting new times with ease. How India solves the Y2K problem. India is a late arrival to the digital world, but it is not slow in solving the Y2K problem. Computers are now common in India in government, business, industry, as well as homes. In view of this, the experts advise the buyers to buy softwares and hardwares which would run these machines with care. The buyers are expected to make sure that the computers and softwares they acquire follow the Y2K requirements. The issue. The annual time frame for computers and software were designed with the last 2 digits. Up to the year 1999. When 1999 is over, the computers, according to the old or existing software, will print 00 for the year 2000, but in computer it will actually be considered the year 1900, a full 100 years behind the real time. Unless corrected, that could be a near catastrophe. The question now is, how is it being solved? It is now necessary that when the year of the date is mentioned, all 4 digits should be printed. This is being included in all new softwares. The cost of doing this all over the world runs into tens and hundreds of billions of dollars. During the early period, the world sensed that airplane flights would be affected in midair and on the ground because today's jet planes and other aircraft are highly sophisticated and computerized. It was feared that health records, especially in the advanced countries, could go haywire and the patient's treatment would be affected. In India, airline and railway ticketing could have been affected, as most of it, if not all of it, is computerized. The approach to the solution. Recognizing this and sensing of other problems which would arrive, an inexorable approach to meet the Y2K challenge has been launched. In India, a task force has been set up with a member of the Planning Commission at its head to monitor the progress and compliance with norms set to meet the needs. India is taking precautions for a few thousand years in the systems now being programmed. After 1999 the software should read 2000. After 2099 it should be 2100. After 2999 it should be 3000 and go up to the year 9999 smoothly. It has been visualized that after 31.12.9999 it will be 1.1.10000 the next day. That is 8,000 years away, far away, indeed, and the resolution of the problem can be safely left to the scientists at that time.